Okay, these next four problems are all water horsepower problems. And so we're going to use our water horsepower formula, which is flow in gallons per minute times feet of head divided by 3960, as seen here on the ABC test formula sheet. So let's go ahead and write this formula over here. Flow in gallons per minute times feet of head divided by 3960. So first problem is pretty straightforward. They give us the flow in gallons per minute, and they give us the feet of head. So all we need to do is plug these numbers straight into our formula. 2,200 gallons per minute times 35 feet of head divided by 3960 equals It's good. If I multiply the top two numbers together, I get 77,000. And then I divide that by 3960. And I get 19.44 WHP, or water horsepower. Second problem is identical, except now we have a liquid with a higher specific gravity. So if you think about this, higher specific gravity means that liquid is denser than water, so that would mean that the pump has to work a little bit harder. So let's set our problem up. Remember, flow in gallons per minute, 320 times feet of head, 45 feet. And because the specific gravity is not 1, because it's not the same as water, we have to factor that in. So 1.15 specific gravity all over 3960. So let's go ahead and multiply this one out. 320 times 45 times 1.15 equals 16,560 divided by 3960 equals 4.18 water horsepower. Now let's think about this problem if we were not pumping that liquid with the higher specific gravity. So let's think about this without that specific gravity for a second. So it would just be 320 gallons per minute times 45. That would get us to 14,400 divided by 3960. So you can see that's going to take less horsepower, 3.63. So you can see the denser liquid would require more effort to lift, so a higher, greater water horsepower. And that's why we have to factor in specific gravity, and why that has to be factored on the top half of our equation. Problem number 3, we're still using the same formula. Flow in gallons per minute times feet of head divided by 3960, except this time, instead of calculating the water horsepower, they want us to calculate total head or feet of head. So we have to rewrite this equation somehow. So how do we rewrite this equation if we have gallons of flow times feet of head over 3960 equals water horsepower? So if we know what the water horsepower is, the first thing that I'm going to do to rewrite this equation is I'm going to multiply both sides of the equation by 3960 over 1. So what that's going to get me, these cancel out here, and I am left with gallons of flow times feet equals water horsepower times 3960. And then because I want to have feet of head by itself, now what can I do? I can divide both sides of the equation by gallons. So let's go ahead and do that. We're going to have gallons times feet of head divided by gallons equals water horsepower times 3960 divided by gallons. Remember, we can do this because we do it to both sides of the equation. Gallons are going to cancel out here, and I'm left with feet of head equals water horsepower times 3960 over gallons of flow, or gallons per minute. So now we can plug our numbers in. So we have feet of head equals water horsepower, which was 15, times 3960 divided by gallons per minute, which was given as 900 gallons per minute. So feet of head is going to equal 15 times 3960 is 59,400 divided by 900, and let's work that out. I come up with 66. So 66 feet of head. We're using the same equation, we just have to rewrite it in order to get the number that we're trying to find on one side of the equation. And we are going to do the same thing here. Remember our formula, gallons per minute times feet of head divided by 3960 equals water horsepower. In this case, we're trying to determine pumping rate in gallons per minute. So again, let's rewrite this equation to get gallons per minute by itself. And I'm going to start with the same thing I started with last time, which is multiplying both sides of the equation. by 3960 over 1. So 3960 is going to cancel itself out on this side of the equation, and I'm going to be left with gallons per minute times feet of head equals water horsepower times 3960. And now, because I want to get gallons per minute on the same, or on one side of the equation by itself, I can divide both sides of the equation by feet. And in this case, feet are going to cancel out on that side of the equation, and I'm left with gallons per minute equals water horsepower times 3960 all over feet. And now that I've rewritten the equation, all I need to do is plug my numbers in. I have gallons per minute, which I'm trying to determine, equals water horsepower, which was 10, times 3960 divided by feet of head, which is 38 feet of head in this instance. So one more time, let's do a little bit of calculating here. 3960 times 10, of course, is going to get us to 39,600. And we're going to divide that by 38 feet of head. And once we do that division, we come up with a number 1,042 gallons per minute. So same equation for all four problems. Just the last couple problems, we have to rewrite the equation so that we can get the number that we're trying to calculate on one side of the equation.